Antibiotics are very commonly used medications, and they have been an incredible tool for curing infectious diseases and saving lives. But there are also some potential negative consequences that can come with taking antibiotics, some of which can be quite serious. So in today's video, we're going to talk about how antibiotics work, the good things they can do for the human body, but also some of those potential negative effects. And of course, we'll discuss some concerns around their future use and antibiotic resistance. It's definitely going to be a fun one, so let's do this. So what are antibiotics and how do they work? Antibiotics are substances that kill or inhibit the growth of bacteria. And one of the coolest and most fascinating concepts that I remember learning about as a microbiology student, and this concept's very important to how antibiotics actually work, is something called selective toxicity. We want these antibiotics to be selectively toxic, meaning we want them to be harmful to the bacteria, but not to our own human cells. And this is accomplished by exploiting the differences between the metabolism and the structure of the bacteria versus our own human cells. And there are some major differences between bacteria and our cells. For example, bacteria have a cell wall. Our cells do not. Bacteria also have some major differences in their ribosomes and their nucleic acids like DNA, and also some subtle differences in their cell membrane. Remember, a cell membrane is different than a cell wall. And antibiotics do a pretty good job at exploiting or targeting these differences. So let's give some examples of how antibiotics work to exploit some of these differences, and then we can discuss some of the good things that antibiotics do for the human body, as well as some concerns or considerations with taking them. And as we get into how antibiotics work, it's also useful to know that antibiotics can be bactericidal or bacteriostatic. A bactericidal antibiotic will actually kill the bacteria, whereas a bacteriostatic antibiotic will slow or inhibit the growth of the bacteria. So if someone were taking a bacteriostatic antibiotic, they'd also need their immune system to come in and help with the killing, because if you remove that bacteriostatic antibiotic, the bacteria could start growing again. But both bactericidal and bacteriostatic antibiotics have been used successfully to treat multiple different types of infections. Some of the most common antibiotics that you've likely heard of work to kill bacteria by inhibiting the synthesis of their cell wall, which is pretty easy to exploit because human cells don't have a cell wall. And if the bacteria cannot link certain components of their cell wall together during cell division, water will rush in, causing the bacterial cell to rupture and die. And like I said, some of the most common antibiotics work this way, the beta-lactams. Now you may not have heard of them as called the beta-lactams, but you've likely heard of the penicillins and maybe even the cephalosporins. A very common penicillin is something like amoxicillin. Maybe you've even heard of a cephalosporin that's commonly used like cephalexin, also known as Keflex. There are also multiple antibiotics that work to inhibit protein synthesis of bacteria without interfering with the protein synthesis in human cells. Now you may have heard me mention ribosomes earlier on, and if you've taken a biology class, you may remember that ribosomes are these cool structures inside the cells that help build proteins. And again, the ribosomes in bacteria are different enough from the ribosomes in human cells that they are a great target for these antibiotics. And if you interfere with the protein synthesis of the bacteria, that could slow the growth or even potentially kill the bacteria. And there are multiple different classes of antibiotics that work to inhibit some portion of the ribosome or some step in this protein synthesis. And I'll give you an example of an antibiotic from each of the major classes. Maybe you've heard of neomycin. Doxycycline is from another class, azithromycin from another, and maybe you've even heard of clarithromycin. Some antibiotics work to inhibit or block certain steps in the process of bacterial DNA synthesis. And I know I sound like a little bit of a broken record, but there are differences in how bacteria synthesize DNA versus how human cells synthesize DNA. So again, another potential difference to exploit. Now, if a bacterial cell can't properly synthesize its DNA, probably not going to be a big surprise that that could slow its growth or even potentially kill the bacterial cell. And there are, again, multiple antibiotic examples that work in this way. Maybe you've heard of Bactrim. Another antibiotic from a different class that you may have also heard about is called ciprofloxacin. Now, I did mention earlier that there are some small differences between the cell membranes of bacteria versus the cell membranes of human cells, but not a lot of differences, and therefore there aren't very many antibiotics that work to disrupt the cell membrane of bacteria. There are a few. Maybe you've heard of the polymyxins or maybe even daptomycin. But again, wouldn't be shocked if you haven't heard of those because, again, not very many antibiotics work in this way. But now that we know the main ways that antibiotics can actually kill or slow the growth of bacteria, how can they help the human body? It probably isn't going to come as a surprise. The main benefit of antibiotics is to treat infections that the body couldn't fight off or would have trouble fighting off on its own. But let's be sure to give antibiotics their credit here. The discovery and use of antibiotics is arguably one of the most important medical contributions of the 20th century. Antibiotics have helped to increase the average human life expectancy and have saved a countless number of lives that would otherwise have been shortened due to infection. However, sometimes us humans have a little bit of a hard time containing ourselves and can use too much of a good thing, because antibiotics are definitely overused to treat certain conditions or infections that shouldn't require the use of an antibiotic. And remember that selective toxicity principle. Even though antibiotics were not designed to directly target specific structures of our own cells to kill them or inhibit their growth, that doesn't mean they can't come with some side effects, potential allergic reactions, or even some level of toxicity with certain concentrations of the drug. And let's go back to that idea of using them too much. Misuse or overuse of antibiotics have contributed to bacteria developing resistance to certain antibiotics, making it more difficult to treat certain infections. So let's give some examples of some potential side effects and even some potential harm that can occur with antibiotic use. And then of course, we'll finish up with more on antibiotic resistance. And some of the most common set of side effects that can occur with almost any antibiotic are GI symptoms, upset stomach, nausea, and of course that wonderful diarrhea, sometimes referred to as antibiotic-associated diarrhea. Now, luckily for most people, this is more of a temporary annoyance and the diarrhea will improve and things will go back to normal after the antibiotic course is completed. Now, there are some people where the diarrhea can get bad enough where they may need to consider changing to a different antibiotic. And one of the reasons why antibiotic-associated diarrhea is thought to occur is due to this use of a broad-spectrum antibiotic. Broad-spectrum antibiotic is an antibiotic that has activity against multiple different types of bacteria. So yes, it would kill the pathogen that's causing the infection, but could also kill and disrupt the bacteria that normally reside within your gut, often referred to as the normal flora. But again, this is often a temporary disruption for most people, and the normal flora can recover. However, there are some people that are a bit more unfortunate and can get things that are worse than the typical antibiotic-associated diarrhea. They can get a secondary infection due to suppression of the normal flora. One of those is Clostridium difficile infection, often referred to as C. diff. Now, those that are colonized with C. diff in their colon, the C. diff bacteria is typically kept in check or held at bay by that normal flora. But when they take certain antibiotics, especially things like clindamycin or ciprofloxacin, but even sometimes the penicillins or cephalosporins can cause this, the normal flora, enough of it can get killed or suppressed that C. diff can start to overgrow, grow out of control, and cause an active infection. And anybody who's had C. diff knows it's no joke. Moderate to severe cases, we're talking multiple bouts of watery diarrhea, abdominal pain, bloating, fever, water and electrolyte imbalances. And in severe cases, they may need to be treated with a fecal transplant or even potentially surgery. Another example of this concept is the development of a yeast infection. Some females may notice that after taking a course of a broad-spectrum antibiotic that they could develop a yeast infection, as that broad-spectrum antibiotic could suppress the normal vaginal flora, allowing that candida or the yeast to overgrow, causing that infection. Another unintended consequence of antibiotic use is an allergic reaction. And I have plenty of patients that have an allergy to a certain antibiotic. For example, it's estimated that anywhere from 1 to 10% of patients can have some level of hypersensitivity to the penicillins. Now, luckily, again, most of those hypersensitivities or those allergies are mild and mostly annoying, like a maculopapular rash, but some, about 0.5%, can have the most serious hypersensitivity reaction, anaphylaxis. Fortunately, death due to anaphylaxis from penicillin is quite uncommon, and there are multiple antibiotics that we can choose from if somebody does have a hypersensitivity to a certain antibiotic but still needs treatment for an infection. So everything we've talked about so far definitely does not cover every potential side effect or reaction that can occur with antibiotic use. That could take quite a bit of time if we continue down that road, but I will include some additional side effects that are associated with some commonly used antibiotics in the description below. The point is, as beneficial as antibiotics can be, they don't come without some associated risks. And that's one of the reasons why we don't want to just use them all willy-nilly. We want to use them when appropriate. Like the classic misuse example, taking an antibiotic for a viral respiratory infection that the body could just get over on its own. Now, we're not just concerned about reducing the risk of unintended side effects by giving somebody an antibiotic when they don't need one. We're also concerned about reducing the risk of antibiotic resistance. Bacteria are pesky little critters that have the ability to adapt and change in order to avoid being killed or suppressed by antibiotics. For example, there are some bacteria that have adapted to produce beta-lactamases, which are enzymes that cleave the structural component of the antibiotic class, the beta-lactams, essentially inactivating those antibiotics. And if you remember, the penicillins and the cephalosporins belong to that beta-lactam class, so those antibiotics would not work well against bacteria that can produce those beta-lactamase enzymes. Bacteria can also modify their ribosomes so that they're no longer a viable target for certain antibiotics. They can also change their cell membrane permeability, and also can create little cellular pumps that can actively pump the antibiotic out of themselves. You can kind of think of this as survival of the fittest in a way. As we continue to use antibiotics, the bacteria that are susceptible will be killed and die off, but those bacteria that are resistant could continue to survive. And they could share this genetic information that codes for resistance as they grow and divide, and bacteria can even share genetic information with other bacteria in their surrounding environment. On one hand, that's super fascinating. On another hand, it's a little bit freaky deaky. But hopefully this gives you some good ideas of the importance of sound medical decision making and only using antibiotics when necessary versus just relying on that good old-fashioned immune system. Thanks for watching our crazy anatomy videos, everyone. Like and subscribe if you feel the need. And of course, leave some comments below. Let us know what you thought of the video, and we'll see you next time.